Okay. We don't need this. Okay. So started recording. Good. Okay, welcome to the fourth class of the summer pre-course, interactive mathematics with Mathematica. Okay. Now, I might as well do a little bit of review. Not so much review, but it's a good idea to sort of like not repeat, but go over what we did so that everybody's on the same page. And it's, in a way, it's a little bit like a mutual understanding that at this point, everybody in the same room should be able to understand certain things, right? Or understand that we have covered a whole bunch of things. So the first day, we didn't do much, right? The first day is about philosophy of multidisciplinary education. I'm a product of one. And so will you be, okay? And that's something quite, it's not new to Thailand. However, recently, it is an exception rather than the rule, okay? I don't know if I ever told you this, but in the old days, Aksonsai was a little bit like Basai. You study all kind of subjects. So if you were a student in Aksonsai, you would also study physics and chemistry and mathematics, right? But then each department got so specialized, so the mathematics, physics sort of like go to a different way. But in the old days, Sonsat is a little bit like multidisciplinary education as well. I think that's my understanding. Okay, so and we talk about what Basai tries to do with you guys, and again the critical idea is that you act a very critical juncture in your life where your lateral dorsal prefrontal cortex is solidifying. It's kind of like becoming crystallized. So this is kind of like a last window of opportunity where you have a very malleable brain. So you can be very inquisitive. You can pack in a lot of abstract intellectual horsepower. This is where you really gain that quite a bit. Okay. And why math? You understand now? Math is not about learning something so you can use. It's not the same thing as learning how to fix your tire so you can fix a broken tire. But mathematics is not task specific like that. And in fact, human beings, the reason that we are the most predominant species on Earth is because we're not task specific. Okay? If we were adapted to be task specific, like fixing a car tire or hunting for bananas or running away from buffaloes or whatever, then we wouldn't have evolved very far. Okay, we wouldn't have evolved very far. We would just have been another species. Okay, so what is good about human being is that we have ability to perform abstract thoughts, and abstract thoughts, as you would call theory, is more powerful because it applies to new classes of problems you haven't seen. Okay. So if you learn how to solve a problem, you know how to solve that problem. But if you know the theoretical underlying of the problem structure itself, the solution methodology, then when you run into a new problem you haven't seen before, you can generalize. Okay, and that's what's going to make you survivable or prolific, even thrive in the new digital economy. Okay, that's even more important. Good. Having said that, you will still have specific skills that will be part of Basai education because we don't want you guys to be, very brilliant, a strategic thinker when you can't, do Excel pivot or something like that. Okay, then you just annoy your coworker. Okay, good. So that's basically the sort of orientation class. Then the second class, I introduce you to basically second and third class, the Mathematica computational platform. So there's the idea of Mathematica as a language itself, as a fundamentally mostly a functional programming paradigm, but that's not the important part. The important part is that you develop this kind of thinking of communicating with a computer through functional call. Okay, and functional call can be thought of as little recipe. Okay, small recipe can be bundled up together, strung together. Output of stirring the eggs can be put into a frying. An output of the frying can be set aside, and you can make fried rice, and you can wrap the fried rice in the omelet. Okay, so think of all the activities, all the algorithms that you try to accomplish as a structure or an architecture of function where outputs of one becomes input of another. Okay, so that's very important. That's very important, and it's even more important, I might say, than learning the syntax. But having said that, of course, you can't do much if you don't learn the syntax. So the syntax is something that I ask you. You have to have readily available. Otherwise, you can't proceed. Okay. I did mention to you about the Wolfram Alpha, which is kind of like computational intelligence, platform intelligence in this case, also referred to information and data. Okay, so it's not just a mathematical function, but it's a function that has real data from real compendium. Nice thing about this is that, and this is a frustration you haven't run into. The data science, and I've run professional data science house. You think you do a lot of analytics and this kind of advanced algorithm. Let me tell you what happened in real life. In real life, you spend about 80% of the time cleaning data, compiling data, making sure data are sort of like in the right kind of like mapping the field and so forth. You spend maybe like 20% developing the model. It's really terrible. That's life. That's life. Now, things are going to get better. This is where big companies invest a lot in data engineering. Okay, so like for example, as you know, I was first senior vice president of quant model and enterprise analytics at SCB. Now, in the old days, the data engineering department was more about storage. Yeah, it was more about how to make sure, well, also security, storage, redundancy, that sort of thing. But not so much about how well we can use the data. So a lot of time, there'll be some data that is sort of like structured data stored in some fundamentally archaic way, perhaps, or maybe some data that's dumped. And so for data scientist side, which is my side, to use the data, we spend, again, 80% of the project time easily, just getting the data from one mini mart to another mini mart. And that's another thing as well you will find in real life. Different department may have its own database and they don't talk to each other. And so when you're trying to do some kind of data science, it necessarily means you need information from here, add to that information for insight. But this was created by, say, a loan department that was created 20 years ago. This was created by an operational logistic department that was created 5 years ago. They use different system, different database. It's a big headache. Anyway, long story short, with Wolfram Alpha, what it does is access kind of like a you can say pre-curated data set, so to speak. Okay, so for you, it's got very nice heading. Say, okay, this is a heading, this is the name, this is the ID, this is the latitude, this is the longitude. It's so nice. It's so nice. So that's a good way to start your project. Now, I'm not saying that this is how you end up doing your capstone project. By the time you get to senior year, you might have to do some project that has to do with, say, health data for Thailand. And that's not maybe deeply, curated, well curated in Wolfram Alpha. So you can get started with Wolfram Alpha for health data, but maybe that's more for like United States or something like that, or UK database. Once you get to your own project, then you have to do the dirty work. That's part of life. That's part of life. Okay. So while you're learning a lot of stuff in Mathematica here, it's so nice, clean, prepared for you. It's like you're learning to be a chef, but the chicken is already cut. The shallots is already chopped. No, everything is all clean. You just come in and throw everything together. In real life, you have to go to the wet market. and get the fish yourself. Okay, something it's a bit like that. Okay, good. So, and we went to the basic primitive. Again, the concept that you have in the back of your mind is functional. So if you say A plus B, somehow in the back of your mind, you have to realize this is a call to a function. That function called plus. That function expects two arguments, one in front, one in the back. But in this case, you can flip them, doesn't matter, right? So A plus B is actually a plus, open bracket, A comma B, close bracket. Yeah. And we have this thing where you have at sign or this kind of type. This is kind of a, see this is the second line. Okay. Now, started on Wednesday, going on Friday, talk about the basic data structure that you deal with, and that's list. Okay, list allow you to store a whole bunch of things in sequence. They don't have to be the same thing, but in most database, a list is a list of same thing. Okay, so like I said, like in the example we saw, right? The first element is number 12. Second element is the color blue. The third element is a string. Okay, but in real application, when you talk about data, when you have a list, it's kind of homogeneous. So this is like a list of student ID and their grades. Okay, and list is accessed by obviously their position. Okay, right. And then we learn the second thing, which is even more powerful, which is association. Now, I'm going to give you a little bit of a mind-bending exercise. Okay, and I write it here. What is actually more fundamental, a list or an association? Think of that, okay? Now, I don't want to spend too much time on this, but I'll just give you two ways of thinking, okay? A list can be more fundamental. After all, you just list things. Association is a list that has a special meaning, right? Right? So it's a meaning that instead of number one is the first element, number two refers to the second element, you have a key that points to the value. Okay, so the association, if I put in Kumjai, it gives my staff ID 1, 2, 3. If Atom Fund, it gives 4, 5, 6. Okay, my nickname perhaps is Paiju, let's say. So when you put Paiju, it also turns up 1, 2, 3. Okay, so in this case, and the way I talked last time, list is more fundamental, right? In fact, I introduced you to list first and association second. But here's a mind bender. Actually, you can think of association as more fundamental, and a list is nothing more than an association whose keys are called position. Right? Think about it. When I say a list, I want the third guy. That's like saying the fundamental object is association, but the key is number 3. Right? Does that make sense? Does that make sense? I have a list of 10 objects, list, open bracket, double open bracket, 3, close bracket, will give you the third element. But that's the same thing as saying, hey, I want an association, but the key that I'm using is number. Okay? So if you flip this around, association is more fundamental. Okay, I'll give you another mind bender. I don't want to spend too much time, so I'll just give you my take on it. What's more fundamental? Association or function? Now, if you learn like a mathematics or like programming, data structure is always more fundamental, right? Function is something you do to it, okay? So association comes first, function is second. But if you think in functional programming, actually what comes first? The function comes first. Association is a special kind of function called lookup function, right? And it works like a function. How does it work like a function? You can have one to many. Can you? Can you do that with function? No, you cannot. That's the only thing you cannot do with function. Can you do one to one? Yes, you can. Can you do many to one? Of course you can. Pumjai and Paiju point to the same staff number. Okay, but if I type in Pumjai, except 1, 2, 3, and Pumjai and 3, 4, 5, 6, that's wrong, right? That doesn't work. Now, what does that mean? That means there's actually two Pumjai. So Pumjai is not enough. It's not enough to work as a key. I have to add the last name. So there's only one Pumjai Namsakun. There's Pumjai this, Pumjai that. Okay, so function actually is more fundamental than association. And association is more fundamental than this. Okay, so you have to have this kind of mental agility. Some people call it mental gymnastics. I don't know if you've heard this word. It's a very popular word in English. Mental gymnastics is a way to say the same thing, but from left to right, from right to left. It's like you're flipping, right? You know, gymnastics, you end up standing, but you do a front flip, you stand. Back flip, you stand. It's a bit like that. Mental gymnastics is an extremely important skill for class size students. That's what's going to make it different. You are not going to be a better Python programmer. You are not going to be a better marketer. You are not going to be a better market analyst. You are not even going to be necessarily a better entrepreneur. Okay, but the mindset here allows you to be that. Okay. So, right, we talked about it. Okay, the map. Okay, that's kind of a good thing. So today, now, again, this is the last time I'm going to give this to you as a sort of like if I were you taking class note. So this is kind of like what you should have been writing at the end of this class. Okay, so this would be something like that. But so now we begin with the fun things. Okay, we start with user-defined function. So today is a function day. Two things. User-defined function means function that you define yourself. And then I'll go to really useful function. Table, for example, is a function. We already talked about that, but it's also a data structure. So we'll talk about functions that are so useful. Some of it has to do with constructing lists and association. Some of it has to do with visualization. And some of it has to do with interactivity. And like I said, today is where we begin to have fun. Okay, this is where we begin to have fun. So let's go to function. Okay, let's go to function. By the way, there was a confusion here. Somebody was trying to name something called precision, right? And you couldn't do it. Why couldn't you do it? Because if you type in big P precision, you will notice that it's already black. That means it's something that the machine already knows what it is. Now, if it knows what it is and you haven't defined it, what's the logical conclusion? It is built in. It is built in. So that means if it's built in, you can't use it for other purpose. Okay. So for in any kind of language, you have a built-in function called print or something. Okay. Now, if you think a print should stand for a variable, you can't. Because every time the computer says the word print, it's going to think it's a function, it's a function, it's a function called print because I know this, I'm built in this. Okay. So when you try to name something, I suggest for Mathematica, okay, this is a naming convention. You can't put blank between text. You can't put funny symbols. You can't put underscore. That's something that is going to maybe annoy some of you who came from Python world because Python world use underscore all the time. Mathematica, you would use like camel case. You know what camel case is? It's when you have the first word is not capitalized, but the second word is next to it, but capitalized, so it looks like a camel. Okay. So the naming convention, you should start with small letter. That way, you know for sure that you're not going to repeat any kind of built-in function. Okay. And if you want to say two word, okay, let's make a. Oops. If I want to name something, okay. Say, my variable is called big cat. I will start with the letter B, small, B-I-G, and then C-A-T. Something like that, okay? So if I did this, it's quite safe because it's one word, okay? So big cat is equal to whatever. So this is my variable name, okay? You can name another thing called small cat, fat, whatever, okay? Small fat cat. Okay, so it's got two humps. This is called camel case. Camel case. Okay, camel case. Looks like a camel. Okay, right. So that's how you name your variable, and it's guaranteed to be safe. Okay. Now let's do this. So let's go to function definition. Oh, not quite. Went a bit too far. I can't. Sometimes I can't. Okay. Ah, there it is. There it is. Wait. Ah. Oh. Too far. Too far. Too far. Too far. Input dynamic. Pure function. No, I want to go back to function definition. Where's my function definition? Ah, okay. Forget the top line. Yeah, I'm writing it because it's again, it's a textbook. I have to be complete, and let's come down here. Where is that? Sorry, pure function. No, I don't want that. Ah, okay. So look at this. Let me make it big. How can I make it bigger? Ah, there it is. Right. Look at this line. Okay, this is what I want you to type. Okay, this is what you to type. Again, notice it's camel case, right? You know what a camel case already? Now, this is how you define a function. I'm going to define two variable function. Now, we talk about this high-level function where you can have some function that takes 5 variable, maybe 4, 3, 2, because there's some optional. We'll deal with optional later. Right now, my function is like plus. Okay, you can only add 2 things together. You can't add 1 thing. It doesn't make sense. You can't add, well, you can add 3 things, but let's say you just have a function that has 2 things. Okay, power or something, a to the power b. Okay, now this is how you write. Okay, okay. Let me go to a blank screen so that make it bigger. My function. Okay. Now you can use the word my as a reminder that it's yours. Okay, that's fine. So, okay, this would be the name of your function. Okay. Once you define this, it's no longer going to be blue. You notice it's blue right now. Doesn't know what it is. You're going to define it. So this is called user defined. Let's say I'm going to define it on 2 variables. Okay, A and B. Now, this is a technical thing. Underscore here, the reason why you can't use underscore in naming. Underscore here is in computer programming is called regular expression matching. Okay, what it means is that it tells a computer to match the pattern. Why? Because this is what I'm going to do. Let's say I'm going to define my function AB. Okay, my function AB, and the oops, sorry, should have it. Okay, my function AB, this is the name. So my function is blue now. Okay, and AB, well, it looks black right now, but you see it's not going to be black. Is equal to, and for function definition, you don't use equality, you use colon equality. You could use colon equality in some case, but I don't recommend. Just say for function definition, it's colon equal. It's like saying that will be equal to. Okay, so it doesn't equal to anything right now, but it's only going to be equal when you call it. Okay, so let's say I do this, A plus B. Okay, okay. Now, you saw that black means the computer knows what it is. Blue means the computer doesn't know what it is. Finally, one more color, green. Green italicized means it represents a pattern matching thing. So it's a variable. In other words, if I say a squared plus b, that is a pattern. You can stick anything for a, you can stick anything for b, right? If I stick 7 for a and 10 for b, what am I going to get? I'm going to get 59. The 7 squared plus 10 is 59. I can put in minus 2 and 5, right? That's going to give you 9 because minus 2 squared is 2, or 4, and plus 5 is 9, right? So what it's saying is that in the future, yeah, so this colon is like in the future, whenever I use this function with a and b, I want to perform this action. So what's this action actually? It's the same thing as plus, right? So that's not very interesting. Let's make it something more interesting. Something like b control, oops, sorry. Control slash 100. I don't know. Like, it's just something stupid. Okay? So this is my function. This is my function. Shift enter. Now, the only thing that has changed, right? The only thing that has changed is that my function is known. So next time I'm going to use it, it's the same thing as a built-in function. So my, oops, can't see the mouse. You keep like, never could. My function 8 and 9. Okay, shift enter, right? So it's going to be 8 plus 9 over 199. So that happens to be this. Okay. This is it. This is the most powerful construct you will have, because this is how you can tell the computer to do anything. It's called function definition. And now, and you understand why this A has this underscore and has this screen. It's saying that it doesn't have to be A and B. It can be anything, but we'll put in that place. Okay? Put in that place. Right. Now, this is called a name function. Okay? Why? Because I name it. I define it and I name it. Okay? Now, there's another slightly more confusing way of writing the definition. I'm just going to give it to you briefly. You can ignore it if you're not comfortable, okay? But for those of you who are going to, say, apply digital intelligence, you do high-power computing and machine learning, AI, and so forth, it's very good to learn this thing. It's called pure function, okay? Same when you go in the world of Python, it's called lambda. But anyway, before we get to that, I'm going to say this. Notice when I write this definition, I have to pretend that I'm working on this thing called A and B, right? And then later on, I can plug in anything for A and B. Now, in a more pure sense of the word, I can do this. I can do this. My function, okay? Let's call it my function number 2, okay? You will notice it's going to be defined exactly to do the same thing as my function, but I'm going to write in a special way. Okay, this function is going to do this. Now I can put equal, because now I don't have to delay what happened when you plug in A and B. I don't write A and B. There's no reference to A and B at all. I do this. I said hashtag, and again, this is something that's a little bit nitty-gritty. For those of you who are not comfortable with programming, you can ignore this, but it is really powerful. So I'm just going to give it to you right away. Hashtag means position. Take the first one. Take the first one. Add second one. Divide by 199. Okay, just same silly question. Now, not done yet. Because this is a pure function, it's defined in this way. You have to notify. You know, in Python it's called lambda. You have to write the word lambda, but it's a little bit cumbersome. So here in Mathematica, you just write ampersand. Oops, sorry. That's ampersand. What is ampersand? Okay. Once you write ampersand, notice what happened. that number 1 and number 2 become slanted green. So that's where you stick your stuff. Okay? So what it's saying now that my function 2 now expect 2 things. Whatever the first thing comes, I put it over here. Whatever the second thing comes, I divide by 199, add them together. This, okay, is how you define. Now, it's still named. It's still named function. It's still named function. But notice, it's more economical. And in the future, you can have what's called pure function, where you don't even have to name it, because you just define it and you use it. And that happens all the time in data science. Why? Why? Well, sometimes you want to name complicated function, right? Like how to make souffle, how to make roast duck, or something like that. But something like chopping, okay? Let's say it's not a built-in function. It's not a built-in function, but your restaurant likes to do a special kind of chopping. Yeah, this kind of like characteristic way of chopping your shallot, very different. And you want to do it for this lot of vegetable. You can actually define this function, but not name it, because it's so simple. Something like this. So instead of add 1 plus 2, add 1 plus 2 divided by 199. Now, can you name this? Yes, you can. But it's like writing a big recipe book that has just 1 line. It's a little bit, underwhelming. Okay, for some really stupid, silly, tiny little function that you are going to use once and throw away, you don't need to do this. You can actually, okay, first of all, if I name it, notice if I name it, yeah, name it, fine. And I call it my function 2, and then A and B, it's going to do this. Okay, fine. Now, what I mean by pure function is I don't even need to name it. Okay, I don't need to name it. And I can apply it to, I don't know, 8 and the 1000. I don't know. Okay. This is sort of like use once, throw away. Okay. And the way it's defined is kind of like monkey see, monkey do, right? Take the first thing, put over here. The second thing, divide by 199. There you're done. Okay. Now, this is called pure function. So right now, you have the most powerful way of instruction. So again, this is called name function, right? Use it, pattern matching. And most of the time, I will be using this, by the way. Why? Because instead of having just one operation, what I'm going to do is going to be complicated. Like, I'm going to actually have this as a list. So instead of a list of objects, I'm going to have a list of, but now it's not a list. It's actually serial extension, something like this. A plus B, or something like something, an exponential, whatever. Okay, so many steps. Okay, and this is how you write a big recipe book. Okay, so when you write a big recipe book, if you're gonna do like number 1, number 2, like this, it doesn't look nice. One of the reasons it doesn't look nice is because a lot of time this thing has meaning. So for example, this function happened to be something like A is temperature. Okay, we can do this. We can do A is temperature, and say something like this. B is pressure, right? And you can calculate something like combustion efficiency or something, some engineering thing. In which case, instead of having the word A, you would use, let's see, temperature, like that. And then, so instead of A and B, which is meaningless, you would write something like temperature plus, pressure. You spell pressure there. Okay. So most of the time, you don't do this number 1, number 2 thing. Okay, it's not very useful. But number one, number two thing, this kind of pure function, you know why it's good? Why it's good? It's quick. And you can use it. For example, I'll give you a good example. Let's say you're working with temperature, right? You're working with temperature. Now, you want to convert Celsius to Fahrenheit, let's say. Okay. So that's a simple question, right? That's a simple thing. What do you do? Now, you only need one number, so you don't need number one, number two. You just need hash. Hash. Okay, let's say you take from Celsius and you make it Fahrenheit. How do you do that? How do you do that? You multiply by 9/5, right? So 9. Yeah, and I want you to type along, guys. Type along. That's the only way you can learn. Otherwise, it's gonna look very disorganized. It's meant this way. It's not kind of like a point-by-point lecture. Okay, so try this. Whatever you are given, multiply by 9. Okay, and let's say the whole thing, control // 5, right? And what else happened? What do you need? You have to add 32, right? Yeah. So this is a conversion from Celsius to Fahrenheit. Now, again, I need to tell the computer this is a pure function. I give it a little signal. Oops, sorry. App. Hey. Where's your ampersand? Ah, there it is. Okay. So now what's a comfortable temperature? My comfortable temperature is 25 degrees Celsius. Right? Notice there's only one parameter, there's only one argument I can put in. I can't put in two, right? 77 degrees. Ah, that's a nice. Okay, that's a nice. Now, okay, type this in first. Type this in. I'm gonna have you type something else. Okay. Remember, is that because it's one parameter, it's one variable, right? I can make it even more precise. Sorry, not precise, more compact. I can use @ sign, right? Right? It's the same thing, right? Right? Now, why do I do this? Because I want to show you how this is usually done in life, in profession. Okay, ครับไปเร็ว Okay. So this thing here is a quick and dirty thing. Like I said, pure function is used for relatively simple operation. Okay. You would do the, remember I told you that you spend a lot of time cleaning data. A lot of time cleaning data is just formatting. So for example, I'm collecting temperature recording for different Jangwat in Thailand. So that's in Celsius. I want to use this model, but I also have data from the, say, United States. And that's obviously in Fahrenheit. So I have to do the other way around, or vice versa. So a lot of time you do a lot of time you do a lot of quick and dirty one-liner kind of thing. Now, here's where it becomes more powerful. Instead of just applying to one number, right? You can imagine that I have a whole list of number, and what was the way of doing things to apply to a list? forward slash, right? Forward slash and apply to, let's say I have a temperature reading of Monday and Tuesday and Wednesday, okay? See? Right? Now, obviously, this one is not in numerical, so what I can do is something else, right? What should I do? I just wrap the whole thing in N, right? Ah, there it is, right? So this is a very nice way of doing things. So imagine that instead of having just 3 numbers, I have 1,000 numbers, right? Instead of, normally if you work in Excel, you have to create another column, right? Copy the formula all the way down to whatever, okay? Now, I can, in just one line, I can transform the whole bit. So this is very useful. And a lot of times it's formatting as well. For example, you can say something like Nai or Nang Sao or Mr. or Mrs. Turn Mr. into M, Mrs. into F or something like that. Yeah, all kind of little things. These are very handy. So that's why I'm giving you this quick and dirty way of defining a function, because you would use it all the time. And the reason you should practice is because sometimes when you go to a community, user community, they don't write the whole thing very long. They write something very short like this, okay? And you have to be able to understand. So what do you do when you see something like this? You recognize with the ampersand that this is a pure function. You look at the hash. Does it have any number to it? No, it doesn't. It's just a single hash. So that means it's a single variable function, right? And what does it do? Well, it multiplies things by 9, divide by 5, add 32, and take a numerical value of it. And in this case, I'm applying to 3 different readings. Okay? I'm applying to 3 different temperatures. So there are 3 temperature reading, 25, 27, 21. Okay? Guys, I'm not going to say any more about putting on your mask. Okay? I have to drive my mom tomorrow. I'm not going to take any risk. You two in the back. If you're not going to wear a mask, leave right now. You. Leave. Give your hand to the PA on your way out. Okay. So once again, when you see this, the first thing that should tip you off is that you have this ampersand sign. Okay, again, if you're from a Python programming class, you will see the word alpha. Okay, alpha is, my bad, lambda. Okay, so lambda is a pure function wave. Okay, lambda is a pure function wave. Okay, good. Everybody's got a mask on. Okay, I'm not going to after. Okay, good. So let's go back to our subject. So this here is a quick way of applying things, right? So now this is called pure function. So now you have 2 of the most, well, it's not 2, it's actually 1. Defining function is the most important, the most powerful way you can communicate to your computer. Because after all, you only go to computer to ask it to do things, right? And because the computer is not a complete AI where it can figure out what to do, you have to tell it ahead of time. Okay, so it's very good at making souffle, but unless you instruct the computer how souffle is made, it's not going to do it. Okay, so function definition is a way of telling the recipe. Now, here's the deal. Once the recipe is there, you can call it as many times as you like. It's going to be super efficient. It's going to be very quick. You can use it inside other function. Okay? So that's function. Yeah. Now, where's the class note? There. Okay? Function. Now, we are going to, okay, so this is actually the bulk of your programming is writing a function. You're writing a function using the function that you wrote earlier. You're writing a function that is built in. Now, okay, let's say this is the second half. So welcome back to the second half of class 4, right? So now that we saw how you could define a function using both the name convention as well as the pure convention, right? So now let's see some built-in function. Okay, so now I'm going to talk about built-in function. Now, Mathematica has maybe 5,000, maybe 10,000 built-in functions. But I'm going to give you right now 3 of the most useful. Okay, right now. Then I'll give you 5 more, but that has more to do with visualization. Okay, so that's like the second half of the second half. Okay, so the first thing is this function called thread. Anybody knows where that word comes from? It's from sewing, right? You thread things through. Okay, never mind. Okay, I'm just gonna give you an example. Let's say I have 2 lists. Okay, 2 lists. Well, let's use that list that we had before. Okay, let's use that list we had before. Let's say that I have lists of names. Okay, let's do that. Okay, that's my name, and this happened to say my nickname. It's not, just for the example. And Adam Fun, who's actually a TA, right? So remember, this is actually the keys. It's constructed, but let's say we start from scratch. Let's say this is my name. List name equal to this. Okay. Oops. Right. Well, I don't need to see the output, so I'm just gonna put the bracket, sorry, the semicolon behind it. Okay. Semicolon, where's semicolon? Where's it? Ah, there it is. Okay. Semicolon. Now, what else? I'm gonna say list of ID. Okay. List of ID. Okay. Now, this one is not realistic because list of ID would probably not be repeating. But in this case, let's say I'm just gonna write 1, 2, 3, 1, 2, 3, and 4, 5, 6 because you know the second one refers to the same guy. Okay. So I'm gonna define this thing. Yeah. Right. Now, okay, this ID. Oops, I forgot the equality sign. It's very hard for me to see there is equal. Okay. Fine. Okay. Now I'm gonna call this thing called my database. Database. Okay, it's not really data. Okay, but let's say my database is equal to list name and list ID, right? Okay. Now what's gonna happen? Anybody? It's a list of 2 objects, each of which is a list of 3 objects. So what's the dimension, guys? 2 by 3, right? Yeah, see that's what that's okay. See dimension of data. What's the dimensions of data? 2 by 3. Yeah, that makes sense, right? That makes sense. Now, 2 by 3 is also a matrix, correct? Normally, right? When we have numbers. Do you guys know what a matrix transpose is? I have to tell you because you have to know what it is. Okay? Raise your hand if you don't know what transpose is. It's basically flipping row and columns. Okay? So let me show you what right now that let me put it in a nice matrix form. matrix form data. Okay, right? So it's 2 rows of 3 columns. How do I flip this around? How do I flip this around? Well, I can do this. First of all, I can say transpose data. Now, just to be sure, let me check. What's the dimension? Anybody? It's going to be 3 by 2, right? Right? Simple enough. By the way, it helps me tremendously for you to sort of, if you get it, do this. So I don't have to wait. So I say, okay, I see. Okay. And so if I do a matrix form of transpose first, right? Transpose. What do you think is going to happen? Huh? What's going to happen? It's going to flip. So the name is going to be in the first column. Simple enough, right? Simple enough. So you can see that transpose flip the row and column. Okay. But this is what I want to do. Instead of doing this, what if I use the word thread? Okay. Watch this. Okay. Watch this. I thread. Okay. And I take the first list. Okay. So again, this is from what we saw earlier. List name, comma, list ID. Okay. Oops. Forgot the bracket. Bracket. Okay. Now, if I do matrix form, it's going to be the same. Right? So you can think of thread as a transpose. You can think of thread as a transpose, but it's more powerful than a transpose. Because if I have a list of name and list of ID and I flip it, all I'm going to do is just list the name here and list ID. But what if I want to do something fancier, like stick an arrow between them? Watch this, okay? So now, instead of thread this and a bracket, what I'm going to do is literally like this. Name, point to ID. Now, what does it look like? I'm going to list name. It says list name, point to list ID. But when I put thread in front of it, it doesn't do it. The list point to list. It goes to each element and then do that. So anytime I have this kind of thread, it's very powerful. I can make any kind of stuff, right? Now, this is going to be a little bit silly, but let's try, instead of doing this, let's do that. Oh, you can do that as well, right? So in other words, thread is going to apply something to something else by element by element by element. So obviously, this is going to be very useful for what? For constructing, right? And in particular, I already used arrows, so the smart one amongst you already know where I'm heading, right? Well, remember that list name ID, right? Remember that name ID is an association. Name, oops. Name ID, right? Remember, we haven't done that, right? We did it last class. This is where Poochai points to 1, 2, 3, Haichu points to 1, 2, 3, Adam points to 4, 5, 6, right? But now we don't have that. We just have my name, Haichu, Poochai, Haichu, Adam font. We have 1, 2, 3, 1, 2, 3, 4, 5, 6. So how about this? Name is equal to association, right? Of thread of, oops, thread thread what? List name point to list ID. And it's exactly the same, right? So what this does is, if you were to work this with spreadsheet, you have to do this kind of, copy paste, transpose. It's painful. It's painful. This you can just use one line, right? And this is done all the time. One of the most useful thing is, okay, I'll say this again. There are two data structures that's going to be more important to your life than anything else. One is table, the other one is graph. Okay, somebody already came to talk to me about graph representation of social network. That's very good. But table, what does table look like? It has columns of numbers or whatever with the name, right? So I can do this. I can say the name of the column point to the content. And that is how we build what's called data set. Okay? We'll go a little bit more to data set. Right now, I just want to show you that thread is so powerful. And I can use it with any kind of thing, right? So I want to do something A and B, but I don't have just one A and B. I have 1,000, 1,000,000 A and 1,000,000 B. Instead of going to element by element and do A and B, I just say thread, list of A, list of B, and it's going to do that automatically. Okay? It's not a complicated operation, but it's so wasteful if you want to do it manually. So it's kind of built in. Yeah, it's kind of built in. Now, and again, this is what happened. Now, Mathematica also takes user response. User like to use this so much. So instead of making it like this, they just call it one function. Association thread. So I can do this. Association thread. Okay, notice it's blue until I finish the word. Okay, list name, list ID. Shift enter, same thing. Okay, so association thread is a shorthand for association thread A, list A, point to list B. Okay, I use this 1,000 times, not 1,000 times. Okay, in a typical data science project, association thread is used plenty. So that's why I'm teaching you specific function, even though theoretically you can look at any function and there are 5,000, 10,000 functions. I'm giving you the bare what I found from experience, professional experience, which I would imagine that you want to have a shortcut access to. One of the most useful function that's used all the time, and it saves you a whole lot. Okay, so that's why I show you this thread association. So compared to transpose, so it's more general, right? Transpose just sort of like flip. In this case, no, you actually say one by one. Transpose is like looking at each column and row, and then flip the row. Now, second most useful, and again, I use this a whole lot of time in professional life. In Mathematica, remember, things that the computer doesn't know is blue. Once you define it, it's black. This, once you define it, it's like an elephant, never forgets, right? So what if I want to use it quickly? Okay, A is equal to 5 right now, but I don't want it to be forever imprinted. Okay, because sometimes I get, you saw that there was something where I defined A earlier, and when I use A sub I, it lists that information. So I have to clear it first, right? So instead of defining it, using it temporarily, and then decide I have to clear it, what I can do is I can localize it in a module. Okay? And that's what module does. So a module, okay, has two parts. Okay? Has two parts. Okay? Notice there's a little red thing because it's saying, you haven't put something, so it's expecting something. Comma. Now, see, it's expecting something. So let's say I want to set A equal to 5 and B equal to 7, and I want to add them. If I did this, I have to clear A and B, right? So what I do is I wrap everything in the module, okay? The first part is a list of local variables. So I'm going to have A and B. And yeah, that's it. And this is my action. Okay. A is equal to 7, right? Now, you start to have many lines, so I separate two semicolon, right? Oops, sorry. B equal to 5. Okay. And then I return A plus B. Now, because it's the last line, I don't have to write return. I can do this. Okay. But because it's the last line, sometimes I don't even bother to do that. It's already the last line. So I just do this. Return is useful because sometimes you want to return something and then skip the rest. Okay. I'm not skipping anything. So there it is. I get 12. Nice thing about this 12 is that in order to make it, in order to manufacture it, so think of this as intermediate product. A and B is like intermediate product. And it has a color green. A little bit like variable that has a green slide slanted, but it means something that is not known elsewhere. It's only known locally. So it's safe. Okay. Now, occasionally, if you look at some of my example code, because the initial assignment is so easy, it doesn't take too much time, I can just do this. A equal to 7. Okay, and it would do the same thing. Okay. Right. But for something more complicated, I would just make it first and then do something to it, right? So this module construction is very powerful. Okay, it's very powerful. It allows you to do all kinds of stuff, but then sort of like contain. And modularity is a big word. What do I mean by big word? It's a word that's used in management consultant. It's used in military strategy. It's a very modern way of working. It's a plug and play kind of thing, right? If I plug this module in, I can be sure, okay, that it's not going to bother anybody else. In other words, I can use it anywhere, and it's not going to make A and B go bad. A little bit like that, right? So module is extremely important. Okay? Now, you see how it's used later? The other thing that's more useful than anything else is manipulate. And this is where the word interactive in the name of this course, right? The name of this course is Interactive Mathematica. It comes from here. Manipulate, from the word hand. Manipulate means use your hand to play with things. So I'm just going to do this. So this is a construct. Just like module, it has two parts as well. So manipulate. Now, the difference is with module, you define the variable, comma, and then you have the action. Manipulate is different. Manipulate focus on the action first. Okay? Let's say my action is A and B. A plus B. Okay? My action is A plus B. However, I want to define A as a range of number. And then B as a range of number. Okay. So let's see here. Okay. Now this doesn't look very nice. Let me do a little bit of cosmetic, but don't worry, it doesn't mean anything. Control placement at the bottom. Okay. Oh. I think I have something wrong with it. Let's make it. Some reason A is. Forgot. For some reason I did. Try it again. Okay. Sorry. It's just a typo on my part. Sorry. Okay. So what does it say? Manipulate has two parts. Manipulate has two parts. What it means is that instead of variable being input by the program, now the variable would be manipulated by the program user. It's what graphical user interface. Okay, so it has two parts. This is the first part is the action part. Okay, the second part has to do with that manipulation. Now, except it's all separated by comma. So, you think it's 4-part, but it's actually 2-part. Yeah. So what it says is that I want this action. Okay. I want this action. I want the action of exponential. Let me just put the emphasis so that you can see that it's okay. Something like that. Okay. Okay, something like this. Okay. No, actually, I'll make it even simpler. I don't make any function. I just write it. That'd be nicer. That way you can see that it's doing that. Okay. All I'm doing is I'm listing AA and BB, but the AA can go from 1 to 5. BB can go from 1 to 7. And this is my function. So now this is the manipulate. See that? It goes all the way to 5, comes back down to 1. Okay, that's my A. Okay. So this is the action. It acts on these two things, A and B, but the A and B is not fixed. It is manipulatable parameter, right? So now I can do this. I can move B. Okay? Right? Now I can do various things, by the way. If I want from A to 5 and in step of 2, I can do that. And notice that when I move, it goes in a step of 2. Right? Right? So basically, this is the list. This is like the table, right? So this is what I mean by this is probably the most powerful, and this is there's almost 2 points in Mathematica in Basic education. One is the interactivity allows you to understand the math, the algorithm, whatever, understand how to play things. Second thing is you understand your product. Your client doesn't understand your product. You want your client to be able to visualize your product. So imagine, well, I'll show you later, okay? Let's say I want to draw, I designed this glasses, right? And it has color blue, orange, green, or something. It has many colors to play with. I want to show my client what the product looks like at the end. I can do two things. I can list blue, green, and red classes in the beginning. That's it. And if your client says, well, I want to see your product in gold, can I do that? Can't. I have to redraw it. In this case, I make this option available to your client. So your client said, okay, this is what it would look like in gold. Right? This is what it would look like in gold. Now, I'm going to skip a long step, and I'll just show you something I did. Okay? Well, maybe later. Maybe it's a little more sophisticated. Now, can you see this? This is what manipulate allows you to do. Now, imagine this. Okay, let's go. Last time we talked about this plot assign function, right? Let's try that again. I don't know how to do it. Plot sine function. Right. So let's go back to remember last time, if you didn't know any better, you can sort of like just type enter equal plot sine function. So it comes up to this. So this is the thing's suggestion. Now, on that class, I didn't show you what happened when you press enter, right? But let's do that. Press enter. Oops. So just put X in there. There. Okay. That's what they suggest. Plot, evaluate function called sine function. That function is applied on this thing called X. This X goes from -6 to +6. It's just a suggestion, like I said, right? But let's say you wrote this yourself. By the way, you don't need this evaluate. Sometimes it's evaluate is like it's used because some function can be very advanced and very complicated and you need to sort of like get the value first. But this works as well. Okay? This works as well. Now, you got this, right? You got this. But now you don't want to just plot. Let's say, I don't know, this is you're selling a product to your client, and this is sort of like a roof, something like that. I don't know. It's a pattern. Okay? And your client say, well, I like this shape, but I want it to be more sort of like, has more peaks or something like that. Well, how do you make the sine function have more peaks? Well, certainly you can do this. You can add a multiplier to it, right? Right? So let's say I'm going to add a multiplier A. Now, you need to put a blank because otherwise it's going to think it's an AX. That's not good. Okay? So, now, this is an action that has everything it needs except A. So I can put A in as a value somewhere else. But now I want to put A in as manipulate. Right? So let's do that. A from say 1 to, I don't know, 5. Okay? It doesn't mean anything. Okay? Put it in bracket. Right? Now, put it in manipulate. Open bracket. Okay? Let's see what happens. See? So now the action starts out with A. That A starts with the value 1 because that's where you start. So this goes from 1 to 5. So this is A is equal to 1. What happened? Anybody? When you add more A to it? Right? Okay. Now, by default, it's going to put this is called the control. Controls are the norm. UI, graphical user interface norms. Right? Graphical interface norms. So I can put this anywhere. I can put control placement bottom. Okay. Maybe that's a little bit nicer. Depends. Okay. So now you can do that. Right? Okay. So this thing here is allowing the user to play around with it, right? Now let's do something even more fun. Okay. Notice what am I manipulating? I'm manipulating the value A. See that? That's the A, right? That A is manipulated from 1 to 5. 1 to 5. Okay. If you write this in Python, it would take you 5 pages. Maybe a bit less with dash, but not much less. Okay. But here you can write this in 1 line. Now, here's a fun thing about it. What's my action? Plot sine AX. Well, it turns out even plot can be changed. Sine can be changed. Let me do this. Instead of putting the word sine, okay, watch this. I put the word do this. Put the word do this. Okay? And I add this option, do this, and I specify. Now, I can't specify with number because number is not a function, right? So what I have to do instead is put in a list of things I can do. What are things I can do? Well, obviously I can do sine, right? What else can I do? I can do cosine. What else can I do? I can do exponential. Let's say let's do this. Okay. Okay. Now, be careful. You have now some of you will notice that it has 2 brackets. Why is that? Because the first bracket say I'm going to manipulate do this. The second manipulate say the choice of function. The choice of function. Right? So let's see what happened. Okay, like before, A starts at 1. Do this, start with sine. So it looks just like before, right? And now you have 2 knobs. One knob control the frequency. Okay. Right? Now this function change what? From sine to cosine. From cosine to exponential. And if it's exponential, the parameter will be interpreted differently. Okay. Again, if you write this with general language, you know, lower level language, Python, whatever, it takes you 5 pages. Well, not 5 pages, but it takes you a lot. So in one fell swoop, this manipulate is what basically is the title of this course. Okay? The content, the action, we will use the mathematics because you have to understand the baseline probability, statistics, calculus, and that's also the job for the pre-course to make sure everybody's on the same page. But the tool here is the interactivity. Okay? Now, you can use this for your, whatever, senior project. You can use this from today until you graduate. Okay? You can use this, not for mathematics, but you can display health science data, sustainability challenge, right? Some of you do sustainability, some of you smart city, right? Okay? So, let's do something fun. Okay, so let me see if we've got this. Okay, right. So manipulate, thread, module. These are extremely powerful. Okay. Now I happen to use plot already. So we go into the visualization next, right? So this is the last bit of today. We might not be able to cover much, all of it. We'll do GeoList plot next class probably. GeoList plot is useful. But so for example, okay, so the difference here, now, I don't want to show you everything now. What I want you to do is pretend that you are learning this by yourself. Okay? All I'm telling you is that there's a function called plot. Okay? And this function called plot, you know, it plots some function, y is a function of x, right? But let's say I tell you that, you know, you can plot three-dimensional plot as well, right? You can plot three-dimensional plot. It's called surface plot, right? So y is a function of x1 and x2. Can you do that? Yes, you can. All I'm telling you right now is that that function is called plot 3D. That's all. That's all I say. Okay? Now, class is over, you go home. I haven't taught you anything. I just said plot 3D. So what do? You go home and say, okay, he says something about plot. Oh, there's a word 3. Oh, there's plot 3D. I don't know how to use it. I don't know how to use it, so I press F1, which I think is I might have problem again. So what? No. Fun. How do I go to reference in your computer? I have to go to help, right? Okay, documentation. Okay, and I type it. But you know, most of you guys should be able to do plot 3D and then just F1. Okay. I'm not sure about MacBook. Who has MacBook? I think it's a different key. It's not F1. I think it's what's it called? Control function F or something. Okay. Right. Okay. You are on your own now. I haven't taught you anything. You come to this page, you read. Ah, this is a function plot. It generates three-dimensional plot of f as a function of x and y. So it shows you, right? So you saw this already before, right? Something like sine of x, x from -6 to +6. But now you have what? Now you have two arguments. So how would you do it? Let's try to copy this and write it. Or better yet, come down here. Yeah, see that? That's a decorative, that's a documentation, right? So you can copy this, put in x min, x max, y min, y max, do yourself. Or you can come down and look at details. Yeah, fine, that's a little bit advanced. Forget the detail. Let's go look at some example. You click on it, and that becomes copy. Again, don't know why yours doesn't. And then do it yourself. Do it yourself. There. What does this do? Exactly. Again, this has a function, sine, in this case, is x plus y squared. Okay? But when you learn by example, it doesn't mean that the example is exactly what you wanted to do. Okay? So you have to pretend. If this were my function, this is what I would want to do. But this is not my function. I want to do something else. Fine. Come back to that later. But right now, you can say, my action is plot 3D of a sine function of x plus y squared, x going from -3 to +3, y going from -2 to +2, right? Once you have this, the cool thing about it is it becomes a 3D object. So you can just click on it and just look at outside, inside. So you get 3D animation for free. Okay? Right? Again, why is this critical for your Bahasa education? Number one, when you try to understand something, you use this to visualize. Let's say you're studying something about robotic control. And in that, it has certain function, response function of a robot. And you look at the formula and it doesn't make sense. I don't understand what happened with X, with Y, what happened. Put it in Mathematica and get the visualization for yourself. So that means you learn something by looking at it. That's a different way and it's more powerful way. Why? And I'll tell you this. Two of the most well-known brilliant minds on earth that people recognize, Einstein, right? and Stephen Hawking, right? They are extremely visual people. Stephen Hawking, because he can't write, he can't, he cannot move his hand, right? He had to visualize everything in his mind. So physics to him is a visualization game. It is that powerful. Now, obviously, we don't have his kind of brain, okay? But we can take a shortcut. So whereas Stephen Hawking can look at y is equal sine of x plus y squared, sort of like, yeah, that's what it looks like. Okay, we're not Stephen Hawking, right? So we put x plus y squared, and then we, oh, okay, that's what it looks like. Okay, so symmetric about y, and as x goes up, okay, I see. Okay, so around 0. So that's purpose number 1. Visualize your object. Number 2, let's say for some reason, this is my design concept. I designed this picture. I designed this thing. I want my client to look at it, right? But not only I want my client to look at it, I want my client to be able to manipulate, right? Right? So let's do this. Let's manipulate. Let's try this. Let's manipulate something. I don't know. Let's do the old trick. Let's do the old trick. Let's add a to it, right? And do this, okay? And then manipulate, and let's copy the old code. Let's do this. Okay, so same basic infrastructure, just different function, right? And then blah blah blah. Manipulate. Right, there we go. Okay, so you go to your client or your investor or whatever. Hey, I designed this thing. It looks good, but it would look better if it has more crease. Let's say you want more crease. Your client wants more crease. Oh, you mean this? Is that what you want? Now, this happened to be crease in the X direction, but you can add crease in the Y direction. Oh, sorry, this is in the Y direction, right? So, well, you can also make it this, or you can also make it all kind of stuff, right? All kind of stuff. So this is how you get your idea to your either client or investor. Basai is supposed to give you this kind of thinking, right? You are visual, you're visual, you translate your visual into the mathematics, right? Because if you don't translate to mathematics, it doesn't work. But once you translate to mathematics, you can't go to your clients and show the formula. Your clients are going to get it either, right? So your client then will have to visualize. And that's the tool you should have. Okay? That's the tool you're supposed to have. So if you develop something like it now, obviously, professionally, you use like simulation, 3D graphics and all that, right? But here in this one package, you have everything from mathematics, plotting, data analytics, machine learning, AI, visualization, graphic 3Ds, okay? And it's a little bit like, again, iOS in that it's not open-minded. You can't really import libraries from other people. You can, but it's not usually how it's done. Most of the time, you use what's there and you write yourself. Yeah. So if any kind of library is going to happen at all, it's going to be your own library. Like I write my own library. Yeah. I do what's called fuzzy theory. It's kind of like a mathematics for investment. And I built my own library. And I use this. Okay. So good. So this would be, for example, plot. Now the difference between plot and list plot, which is another thing, again, I'm not here. You just look at it and you just, you hear I say list plot, okay, list plot. All right. So you go to help and you type in list plot. Well, actually, you saw that already. By the way, when you go to here, this is more like a tutorial in here. So it goes by different subject. It goes a lot deeper. It's almost like a self-taught. Okay. But here, you're just looking up something. Let's look up, what's it called? List plot. Now, list plot, you happen to see already last time we did this. So all kind of example. Now, down here, it does suggest something else. There's also list line plot. There's also list plot 3D or something. So let's try list plot 3D. Okay. Yeah, list plot 3D. Now, what makes this different from plot 3D? Plot 3D is used for mathematical function. List plot is used for data points. List, plot list, okay? Now, if it's list plot 3D, it's going to give you the surface, but the surface is not a function of x and y, but actually a whole bunch of points, x, y, and z, x, y, and z, right? Except sometimes it's you have this thing where if you want to watch individual point, you don't want it to be smooth. Normally it's smooth. So this will be something that you can play on your own. Okay? Right? So it's almost like from my experience, I know what I use. So instead of giving you a dictionary of English and German, I said, you know, if you don't go to German, these are the 5 words you're going to use a lot. It's a bit like that. You have the dictionary. Every one of you, when you go to that language help, has a whole dictionary. But I'm just giving you that, you know, if you're going to speak Mathematica, these are the words. These are the words I've selected for, pre-selected for you. Okay? Association thread is not on page 1 of documentation, but I can tell you from experience, professional data science, it's extremely convenient. Okay? So, if you look, oops, okay. Now, radial axis plot and geolist plot, maybe I'll give it to you next time. Radial axis plot is like a spider web. You guys see that? You actually think you might have a kind of like a personal assessment from Chulalongkorn University, like skill set, you know, like imagination, perseverance, courtesy, diligence, accuracy, or something like that. Okay, these are characteristics of a perfect employee, and then you will do an analysis. And the reason when they give it to you, they're not just going to give you a number; they're going to give you what looks like a spider web. Okay, so you can be strong in analytical skill, but weak on courtesy. So employer is not going to employ you. You can have good courtesy and respect, and dress it really nice, but you don't have analytical thinking. Well, they're not going to hire you either, right? So you basically you want your spider web to be, you know, big and even, but it's not. It's not possible. Nobody is like that. That's a perfect human being. What it does is it says you're strong in this area. Let's highlight. You're weak in this area. Let's work on it. Okay. So anytime evaluation. By the way, that's a skill in life, guys. When you were a kid, when your mom said, you're a bad boy, you feel bad, you feel like you're a bad boy for life. That's not the point. The point is that it's a feedback system. So when you did something like you kick a cat or something, okay, and your mom said, good boys don't do that. Okay, you kick a cat, the cat cried, you're a bad boy. It's not a permanent branding. Okay, that's why I have no problem. I can tell you off. I can be mean and I can sort of like say how bad you are. Doesn't bother me because I know that it's a state. It's a fleeting statement. Okay, let's say you came in late. You're terrible. You're not punctual, but that's not a brand. You can change it tomorrow. Okay, so always welcome criticism. I can tell you this. I only remember 2 teachers by first name and last name from Sathit Jula. I graduated from who I did graduate. I didn't graduate from high school. I finished Moscow or something, and then I went eventually to the United States. So I didn't finish high school here, but I only remember in 8 years of education from Satikulan, I only remember 2 teachers. Okay, and one of them disciplined me so hard that I cried. I literally ran away from school. Okay, but that made me a better person. Okay? So criticism is good. It's not a branding. It's not a labeling. It doesn't stick with you for life. It's something to point. So when you do this kind of assessment, this kind of radial axis plot, you will see some area where you actually close to origin. That doesn't mean that's you. For example, you can have like a weak communication skill. That only say, work on this, work on this, work on this. Okay? Anyway, that's long story short, that's radial axis plot. It's radial because it goes like this. It's an axis because each line, and you can have 6, 7, 8, 9. Geolist plot is something that I'll just show you briefly. For example, let's say, I'll just show you the picture, okay? For example, if I go to Thailand, let's go. I'll do it later. I'll do it next class. Okay. Basically, instead of treating coordinate, it's actually treating coordinate as position. Okay. So when you plot it, you can say, I'm plotting Bangkok. And I can draw like 3D, geographic, whatever. Okay, so let's do that on Wednesday. So Wednesday, we'll pick up where we are leaving off today, which is a radial axis plot and math plot. And then we start to go into mathematics. Now, this is again the concept of visualizing mathematics. And we will start with number 1, concept of number, space, set. 2, linear algebra. Okay? Linear algebra. Remember I told you? Linear algebra is so important in your life. You're learning it right now. And some of you have already started learning in high school. When I was your age, linear algebra did not matter as much as calculus. Because people who were doing analytics were engineers, not data scientists. Data scientist wasn't a real professional. Right? So I learned calculus in high school. I learned linear algebra as a second year. Things are changing now. You guys are learning linear algebra freshman year, if not in high school. That's because it's become cornerstone of data science. And your world is going to be driven by data. Okay? Good. I'll see you guys on Wednesday. Hopefully you brought your umbrella. Come on. 3D what, sorry? Oh, plot 3D, yeah. Or the this one. Okay. Come on. Yes, sure.
So for mine, it doesn't have the slider, the control panel. So I'm not sure why.
I can't see because it's so small, but you have to make the font big, I can tell you.
How do you make the font?
Control class or something. Yeah, so there has to be a line that's a manipulator.
Yeah.
The outside.
Do this.
But you yeah, guys, quickly, this from your friend's lesson, you notice nothing will happen unless you match this with this. So your action has parameter, but it has to have the same name. So you can see the screen. If you leave this different, it's not going to match. It has to match between the green thing on top and the green thing at the bottom. Sorry. Yeah. Tell you what. Submission today. Let's make it the same 8 o'clock. But it would be nice if you go to those different pages. Plot 3D. Let's plot 3D. Do something. Explore on your own. Okay. The more effort you put into it, the better you get out. So let's make it 8 o'clock. Okay, ครับ see you Wednesday บ๊ายบายสวัสดีครับสวัสดีลูก